Thank you. I left out my curse words in this title. If you've heard the term serverless and you've thought that it has to use servers, you're right. But there's a reason they call it serverless, and that's what this talk is to discuss. My background is actually servers. My company does hardware automation. So I know servers really well. We also use Lambda and things like that on the cloud. So we sort of live both sides of it. We understand how this automation works. And so it's important to understand why serverless, why not functions as a service or something else. And the simple answer is because running infrastructure sucks. It's hard to do. It's hard to maintain control. Developers don't want to do it. It's a distraction from their job, right? Very simple. What they'd really rather be doing is working on things that don't require them to think about PKI infrastructure, right? It's very hard to have a secure, trusted infrastructure, especially internally. That's hard. That's an operational task developers don't want to mess with. They also don't want to deal with load balancers, right? If I'm building an application and scaling it, I don't need a load balancer on my desktop to deliver an application. But if I'm doing it in production, I care about that. Changing that, setting it up, managing that, hard work. That requires a lot of effort. Developers don't want to spend their time doing it. Firewalls, even harder. Having to maintain a production firewall and not let things in and out blocks developers. They say, I don't want to spend time doing that, but it has to be done. All of these things are infrastructure constructs that slow down developers, especially in their own mind, and they have to deal with things like, how do I get it to network? How do I deal with a software-defined layer? All this stuff, we want it to just go away. We want to write code, we want to write functions, we want to make sure that the stuff we're delivering has value. And that's why we call it serverless. Not because it doesn't use servers, but because it doesn't put us in an infrastructure mindset. It's really a rebellion against infrastructure and having to do that type of operational work. This is a DevOps show, though, right? That operational work is what keeps the lights on. It's essential to make things go. So we're in this very interesting challenge where we're adding things like containers, where we're letting developers write code, package it, and ship it, and not worry about how ops works. But they really have to. It has to be part of this pipeline. We have to think through how we're taking those containers and turning them into actual services, something we call microservices, and deploying them in a way that's successful. That's hard. That's an operational construct. It's part of the conversation that we have as we think through function as a service and containers. Part of that means using something like 12-factor apps. If you're not familiar with 12-factor apps, read about it. As an operator, you need to understand this concept. It changes the configuration models for how software is delivered. It's a very important part of this whole change. And there's a lot of wins for operators and DevOps and practitioners in this whole change into functions as service and API-driven code. A big one is cleaner APIs. We're getting much better about creating and specifying APIs. We're using much stricter patterns, and we're looking at how the systems are fit together. We're not just saying, oh, write anything you want. Function as a service actually has very small, very controlled units. Control is good when it comes to creating repeatable, secure, safe code. It means we can do things as operators and say, we're going to have centralized logging. We're going to make sure that people emit logs in standard ways, that we collect them in standard ways, we monitor them in standard ways. That reduces a lot of complexity in running an infrastructure. It's a very important win for serverless. Same thing is true with reducing access. When we're doing serverless and containers and things like that, we don't have to give people access to the infrastructure. They don't want it, we don't give it. That creates security, it makes things more sustainable, creates a better relationship between operational delivery and code delivery, which then lets us look at system-wide concerns. So we can look at a system-wide function, we can look at how things are operating, because now operators are running platforms, those platforms become system concerns, and now we're actually having a much more positive conversation about delivering code. We're able to talk about CI/CD pipelines and actually running things through. That's a huge topic of conversation the last 2 days, and it's a major win as we deliver smaller units of code. It's easier to put them into pipelines, and that's a major part of why people want to do this. It also lets us look at things like A/B testing with rollback and functions. So now, those small units of code put operations in control as they look for, how am I delivering this? Is it right? Is it good code? We actually now have better collaboration between what's being delivered and what's being written, right? Huge wins. That way you can have automatic failover. You can look at how, if something's broken, operations can say, well, we're going to turn this back. or we're going to change forward into the right working code. All those things aid us. Functions as service is good. So things are looking really good for developers, less infrastructure, more time coding. But things are also looking good for ops, because as we're getting into this, we get a lot more control. But you need to be able to have a lot more operational chops to make all this stuff work, something we call site reliability engineering, another whole topic of its own. So thank you very much.